Hello and welcome to Visual Reasoning for ProAV Module number 2. We're going to go from understanding to action. We're going to control a PTZ camera with AI. We're going to draw some detection boxes, and we are going to progress through our visual learning book and online course. So let's jump in. Now that you understand the foundations of visual reasoning and AI and visual language models, now we're going to actually apply this 5-stage ProAV pipeline and really draw some detection boxes around items that we're detecting with our visual learning model. We're going to be interpreting the confidence scores and using them to do decision making. And we're going to build an object tracker. I've got Cursor up and running, so we're going to customize the open source code that's included in the visual reasoning playground. So just to refresh, we got this 5-stage pipeline where we're going to be getting media. Every single visual reasoning playground tool has a built-in baseline video that you can use, but you can always use a live video. So you can use NDI video sources. You can do that with the NDI webcam tool, and I'll show you how to use that. You can use a webcam. If you can convert RTSP to a webcam using OBS or vMix, you're using the virtual webcam tool. We'll talk about that later in this course. But we're going to take media, we're going to send it to a visual reasoning model, we're going to make some decisions, and we're going to control some software and some ProAV equipment. Today will be a PTZ camera. Very excited about that. So let's talk about how this works, and then we're going to make it happen. So this is an example of tracking a speaker. And what we're going to do is we're going to take the camera feed from the back of a room. We are going to detect a person in a blue shirt because there happens to be a person in a blue shirt presenting today. This is interesting because instead of just choosing a person, we're choosing the specific person that we want to track. And this is a really good reason why visual learning models are interesting, because they confirm who's speaking. They're going to return back the coordinates. We're going to use those to steer a PTZ camera, but only when we have high confidence levels to do so. So we're going to be sending pan, tilt, zoom commands to a PTZOptics camera using an API. PTZOptics cameras support a really easy to use HTTP API that's very easy to integrate into our platforms. What gets returned oftentimes is a bounding box. And what that is kind of X and Y coordinates for drawing a box around an object. And this is important because it allows us to say, okay, it allows us to do like headroom, right? Like how much space is above and below the top and bottom of this object, so that we can decide, do we need to zoom into the object? Do we need to zoom out? Where is it? Do we need to pan left? Do we need to pan right in order to center it? And so having trust and transparency are super critical here. So when we get these detection scores, right, if you get a 95% confidence level, which would be expressed as 0.95, we would be very confident that that is definitely a man in a blue shirt, for example, if that's what we're looking for. Between 80% and 94%, we're confident, meaning we can act, but we're going to have guardrails. And we'll kind of explain how this works. If we're 50% to 79%, we're not really sure. We might not want to act on that. You're going to have to do some testing and decide, okay, it's a signal, but is it a good enough signal to actually pan or tilt the camera, make an automation switch in our ProAV system? Maybe not. And then, of course, anything less than 50% is low confidence. And we'll talk about how to increase those confidence scores, how to provide context to the visual learning model, for example, so that it can be more confident. And we'll look at all of that in this course. Now, you want to use the right tool for the right job, and I want to really express this. Not all AI is created equal, right? You might have a really big large language model or a really big vision learning model that has got billions and billions of parameters and it's incredibly intelligent. And then you might have a computer vision model that literally is super fast, super small, but can only recognize hand gestures or can only track a human. And that's why it's so small and so speedy and so fast, because it's really only looking for one object. So vision learning models, now Moondream is one that is also very small and can be run locally on a computer and is very affordable. And that's why we're focusing on it for this course, but it's never going to be as fast as a really small computer vision model. So what we're going to do in this course is we're going to be showing how computer vision and MediaPipe is a free tool from Google that's open source that we will be using in this course, and we'll look at it actually in our next module. It might be a lot faster, a lot lower latency, and that's super critical when we are using auto tracking. So we will be comparing that in the next video, but for now, we're just kind of like thinking about how VLM's super flexible, no computer vision training, traditional computer vision super fast and super reliable. Now, the trade-offs with VLMs, the strengths are that we can track any object, and we're going to show that today. No training. We can use natural language prompts, and it understands the scene. It knows who the presenter is. That's very hard to train. In live environments, in ProAV and broadcast, we can't train a model for all the different scenarios that could happen. It's just not going to work. But the limitations are that we have higher latency than we're going to see in a computer vision model. It's going to require either API keys or a local GPU, and it's really not quite as precise for fast motion because we're not getting as many references with a VLM. It takes longer, and you just physically can't do it with the technology we have today. So some of the trade-offs, again, with computer vision is that the strengths are it's super fast. We can do 30 frames a second. It can run in a browser. We don't need an API. There are really nice open source computer vision models that we're going to look at in this course. In fact, next module, we'll compare side by side these. It can run in a browser, no API needed. It can do precise landmarks, it's battle tested, but it only detects what it's trained for. It can't track the red mug on demand, so it might not really be that great for broadcast and ProAV because it's really purpose built. Now let's talk about when to use each. So is the target a person, a hand, or a face? We probably can use MediaPipe for that. It's an open source, Google MediaPipe is a really great tool for computer vision. We can use it for that. Does it need to be super fast? Is latency critical, which it often is? Then MediaPipe or traditional computer vision is also probably the right case. But do we need natural language descriptions? Do we need to randomly say, hey, the person I need to track is in a blue shirt? The person that I need to track is the person that's most likely the presenter, right? This is where automation really comes in. And this is where testing comes in. If the VLM can do the job, it's going to be way more flexible to work and perform in the real world when things change all the time. So we have to do some prompt engineering to get good detections, right? And this is a great example on the right here. If you're just asking for a person, there's lots of people. And this is the problem with using computer vision to track a person. Which person do you want it to track? It doesn't know the difference. But a VLM would say, oh, the person in the red shirt, that's that specific person. The speaker at the podium, the person closest to the camera, we can start to really get much better results by using a VLM. So you can see here we're getting specific people, contextually aware detections, and spatial reasoning. So this makes the future of AI, as this gets lower latency, right, and more powerful, this is going to replace computer vision in a lot of scenarios where we need that specific person to be tracked. So today we're going to jump into a coding deep dive. We are going to actually use Cursor to make sure that we have our project all set up properly. We're going to use Moondream. And then I'm going to do MediaPipe in the next video because I don't want these to be 20, 30 minutes each. But we will look at MediaPipe. We're going to draw detection boxes and explain how that works. We're going to auto track a person. So I'm going to be centering myself using a VLM. We're going to be capturing frames of video, so just an individual frame at a time, sending it to Moondream's API to get the coordinates of where the thing is, the object that we're tracking. And then we're going to draw bounding boxes, and we are going to act, meaning we're going to control PTZ camera. So this is going to be exciting. Let's jump in. First of all, I have Cursor opened up, and I just wanted to make sure you guys have gotten this far because this is going to be an important piece of this, right? And we're going to use Cursor to actually operate and change the files because I want to show you how easy that is. This is just, I've been talking to it a little bit just to get my visual reasoning programs all set up. And let's start by looking at the visual reasoning playground because this is where you guys are going to be able to do things like drawing detection boxes. And let's go ahead and get started. It's opening up my video, which we will be using. But as I said, we also have these sample videos built in. So if you're not ready to use your own live webcam, you can use this. So on the left-hand side, as we know, we've got all of the status of what's going on and what's happening. So you can understand behind the scenes what's going on. And then what we're going to do here, and I've already got my API key in. Okay, so you're going to have to do that for Moondream right now. And we discussed you can get your API key at moondream.ai. It's free. Create an account, get your API key, plug it in. Now, the first thing I'm going to do is I'm just going to detect the objects that we have here. We got a glass of water, we got a laptop, and we got a coffee. Okay? Boom. We just got our detections. Now, detections, by the way, can have different size borders. We can make the labels bigger or smaller. And these are choices that you make as a designer. Let's add one more here. Let's also look for phone. And we can change the color of it too. Make it kind of like yellow. Okay, let's go ahead and detect those. Now there we go. Boom, we detected a phone. And I'm looking at this here. That was really fast. We got all that information. So we're getting a detection box. We're getting a center point. The center point's super important if you are trying to make decisions based off of where that is. And you'll notice that the boxes are a little off because what's happening is live video continues to move. And these detection boxes, when we click detect, it's happening once. Okay, boom. I click that button, I get a new detection box. It looks like it found it in half a second. Not bad. These are the confidence levels. Man, 100% confidence here that these are the correct objects. So very straightforward stuff here. But if you want to do live video, which we're about to do here, and control a PTZ camera, we need to be sending detections much faster than half a second. So I am going to run this on my local computer, okay? And just for the heck of it, we're going to make some changes to this via cursor so that you can understand how you can customize and change this too. I'm excited about that for you guys. All right, so let's just track a face. What this does is, so I have my PTZOptics camera in here. That's the IP address. If your camera is not set to accept authentication, you may need to turn HTTP authentication off, or in an updated version of this, by the way, I'll show that we've already, just as an important little piece here, in the framing assistant here, we have this enable HTTP authentication. So if your IP address of your camera is not connected or not being controllable, it may be because you need to turn on authentication, which we fixed in the most recent update. But you shouldn't have a problem with that. Let's go ahead, and I have my camera connected, and let's just detect a face. Okay, so it sees my face, but what it's doing is it's also trying to center my face. Okay, so you can see here that this could be kind of valuable, right? You got a couple cameras in here, and you want to make sure that the face is centered in the frame. So if you have 4 or 5 or 6 cameras pointing at different people and they're moving around a little bit, you can have the camera automatically move like this. Pretty cool, right? Now, let's imagine that we're not looking for a face and we're looking for a phone. Okay, I have a phone here. Oh, now we're going to center on the phone. Doesn't have to be a human. Doesn't have to be a face, right? We can track anything. Now, this is not tuned to the way that it should be, right? It's moving a little robotically. That's okay, right? Because, this is proof of concept right now. We could make it better. Let's think of a way to make this better. How would we make this better? Because I want to show how we can use cursor without any knowledge of computer programming to make this a lot better. So what could we do to make this better? Let's just for example, let's have target object. Let's have some predetermined target object options for our users so they don't have to type anything in. So let's go to cursor and say so what will we call this? This is the PTZ framing assistant. For the PTZ framing assistant, let's give users some buttons to click to choose between face, person, and phone so they have those options and don't need to type them in. All right. This is cool because we haven't done this yet. We're going to add buttons to this. It's just HTML and JavaScript. Doesn't take long for Cursor to read the files, change the files. Here we go. I love watching this because, man, it just takes so much time to communicate with programmers, to get what we need done, to test, bug check, right? Okay, boom, that's done. All right, and before we leave here, can you also add a dead zone in the center that I can alter so that the camera doesn't move in that area? Okay. So I'm going to have it add a dead zone as well that we can adapt, because once the object that we're looking for is centered, it's nice to be able to say, is that a big area? Is that a small area? And so I just want to give you an example of this all working here. Looks like it's almost done. So let's go over to our code and take a peek at this. All right, let's refresh it. All right, beautiful. So I wanted to do this so that you could see just how easily we can start to customize and change this. So let's look for a face. All right, so I've got my face, and I've got my phone, and I've got my person options here that I asked for. Let's stick on face. I also have my dead zone here. Look at how easy that is to get little changes and optimizations for your project. The dead zone, pretty good. I like that. So now, let's go ahead and auto frame it. Oh, got to connect. Auto frame. All right. So now when I'm in this dead zone, right, when it has truly centered me, it won't move. And we can decide how big that dead zone is going to be. We can come over here. Let's see if we can hot swap to phone. Okay, so that would be another feature that we could add. Let me stop, switch to phone, auto frame. Oh, it's still on face. Okay, so sometimes there's a few, we have to discuss that with I'm not sure why didn't switch to phone there. We've discussed that with Cursor a little bit, but you guys get it. I've done a lot of projects like this. There's testing involved, there's changing involved, but you can see the UI is not too bad. Did pretty much what we need. Oh, we need to do a little testing. We need to do a little changing. That's understandable when you are working with an AI coding agent. So that's actually something that we can learn from. So we tested all of that. We did some Cursor agentic programming. Let's talk about the key takeaways here. So this 5-stage pipeline is where we're kind of living here, getting media, audio and video into the reasoning system, making decisions and controlling things. We drew bounding boxes, which returned to us normalized coordinates and defined detection areas. We got confidence scores back, which allows us to really trigger our automations properly. And we learned about choosing the right tool for the job. And we put some guardrails in, right? That's what that dead zone was in the middle, right? And we're preventing bad behavior by doing so. So congratulations on completing Module 2. Really cool stuff. It does require playing with the playground, testing, using this stuff. So I hope you're having a lot of fun. Module 3 will be about control systems on automation. And I'll make sure we show computer vision versus a VLM. That's going to be an important step. I'll see you guys in the next one.